Sometimes in math we're presented with equations that are more difficult to solve, and so an adage is always to look for a simpler equation and solve that one. Here on this example, what I see is the absolute value, and I also see the structure of something that needs factored. And so to bestow some power on you, you now have the ability to say stuff like this. Let the absolute value of x plus 3 equal, and then call it whatever you want. Let's call it a. Now if I call that a, I can rewrite this original problem and say 2a squared minus 13a, bring this 15 over as a plus 15, equals 0. This allows me to factor this out, find solutions, and then come back and go back through my substitution to actually solve for the absolute value of x plus 3. And so what I'm saying is it's a higher order of substitution. I'm using this substitution of absolute value x plus 3 equal a to solve this using factoring techniques, and then I come back and I go back to the original problem. This is what I mean. If you are factoring this, we're going to look at this as an AC problem. 2 times 15 is 30. I want to break 30 down so that I can match up the middle term of negative 13. The factors that would allow me to do that would be negative 3 and negative 10. So I factor this as 2a and a. That's your first with first. It's the only way I can get 2a squared. And then these numbers have to be my outer, inner products. So 2 times what produces negative 10? I can say negative 5. That's outer. That forces inner. 1 times what produces negative 3? Negative 3, equaling 0. Now I know you've factored many a time in your mathematical careers, so the next step is to look at the solutions for this factored form. This one would lead us to a equaling 5, and this factor would be 3 halves, so a equals 3 halves. But my original problem didn't have a's. My original problem had absolute values. So as a second phase, I now have to bring the absolute values back in, and I can say something like this. The absolute value of x plus 3 is equal to 3 halves. The absolute value of x plus 3 is equal to 5. From here, each of these statements can then be split into 2 more statements, because when you solve an absolute value, you solve for the positive and the negative result. So I could say x plus 3 is equal to 3 halves. X plus 3 is equal to negative 3 halves. And then in a similar way, I can say x plus 3 is equal to 5, and x plus 3 is equal to negative 5. As I solve this, I can move that 3 over. So 3 halves take away 3 would be negative 3 halves. And then when I move this one over, I can say x is equal to negative 3 halves minus 3, which would be, what do we got here? 6 halves, so that would be 9 halves. Negative 9 halves. On this one, I simply move the 3 over, so x would equal 5 minus 3. X would be equal to 2. On this one, x is equal to negative 5 minus 3, so x is equal to negative 8. Now, once you have all those answers, you do want to make sure that you list these from least to greatest. And so this is more a favor to me than anything else. I don't want to be looking at 100 different ways of you expressing your answers. My least value here is negative 8. So I go negative 8. The next smallest would be negative 4.5. That's negative 9 halves. So I'll say negative 4 1/2. The next smallest is negative 1 1/2. And then my largest was 2. So I list out my finite solutions from least to greatest. Finite solutions because I can count them. 1, 2, 3, 4. There are 4 answers. All of them would work. That's how you would do the substitutions, the substitution problems, where you have something that's more difficult. You go to an easier problem. You find a problem within the problem. You could do the factoring here. You go back and resubstitute back in the original terms, and then you solve those.